Hey, Space Cadets, welcome back to the channel where we explore the mind-blowing wonders of the cosmos. You know, we humans, we love to categorize things, to put things in neat little boxes, and one of the boxes we've put space in is the silent treatment box. You know the drill. In space, no one can hear you scream, but what if I told you that's not entirely true? That's right, folks. Space has a soundtrack, and it's way more metal than you might think. From the roar of solar flares to the eerie whispers of distant galaxies, the universe is practically bursting with sound. So buckle up, because today we're diving headfirst into the cosmic soundscape to uncover the universe's hidden symphony. If you're as fascinated by the cosmos as I am, hit that like button and subscribe to the channel so you never miss out on our mind-expanding space adventures. Okay, let's start with the basics. We all learned in school that sound, the kind our ears pick up here on good old Earth, needs a medium to travel. Sound works the same way, only instead of kids, it's vibrations traveling through air, water, or even solid objects. Now, space, as we know, is mostly a vacuum. And a vacuum, by definition, means no air. No air, no medium for sound waves to travel through. So naturally, we've always assumed that space is the ultimate silent movie. But hold on to your telescopes, folks, because the universe loves to throw curveballs. It turns out, space isn't as empty as we once thought. Sprinkled throughout this cosmic canvas are clouds of gas, dust, and charged particles called plasma. And guess what? These particles can vibrate. Scientists have figured out how to translate these electromagnetic waves into sound waves that we can actually hear. All right, space fans, are you ready to have your minds blown? Because it's time to ditch the textbooks and dive into the real deal, the actual sounds of space captured by NASA and other space agencies. First up, let's pay a visit to our very own star, the Sun. Now, we all know the Sun is a giant ball of hot gas, constantly churning and burning. But did you know that this fiery inferno also produces sound? It's true. As the Sun's plasma churns and bubbles, it creates pressure waves that travel through space. Thanks to the magic of science, we can convert them into audible frequencies. And what do those frequencies sound like? Well, imagine a deep, resonant hum, like a giant gong being struck repeatedly. Next, we're taking a trip to the ringed planet Saturn. Back in 2002, the Cassini spacecraft detected radio waves emanating from the planet's poles. These waves, known as Saturn's kilometric radiation, are generated by the interaction of charged particles from the Sun with Saturn's magnetic field. And when these waves are converted into sound, they produce a series of eerie, otherworldly whooshing and whistling sounds. Remember black holes? In 2003, astronomers using NASA's Chandra X-ray Observatory detected sound waves coming from a supermassive black hole located 250 million light-years away in the Perseus galaxy cluster. These sound waves, the deepest ever detected from an object in space, were generated by the black hole's immense gravitational pull, which creates ripples in the surrounding gas. And what do these black hole sound waves sound like? Well, imagine a deep guttural hum, like a cosmic didgeridoo being played at the edge of reality. It's both terrifying and mesmerizing, a reminder that even the most enigmatic objects in the universe have a voice. Chapter 3. Deciphering the Cosmic Symphony, the Science of Sound in Space. Now, you might be thinking, Neil, this is all mind-blowing stuff, but how do scientists actually make sense of these cosmic sounds? Is there some kind of universal translator for black hole burps and solar flares? Well, it's not quite as simple as plugging in a universal translator, but the process is just as fascinating. One of the key ways scientists analyze these sounds is through a process called spectroscopy. Now, remember those spectrometers we talked about earlier, the ones that break down light into its different wavelengths? Well, they're not just good for identifying the chemical composition of stars and galaxies. They can also tell us about the movement and temperature of these objects. When an object in space moves towards us, its light waves get compressed, shifting towards the blue end of the spectrum. This is called blue shift. Conversely, when an object moves away from us, its light waves get stretched, shifting towards the red end of the spectrum. This is called red shift. Now, the same principle applies to sound waves. Just like light waves, sound waves also experience a Doppler effect. So, by analyzing the frequency of cosmic sound waves, scientists can tell whether an object is moving towards us or away from us, and how fast it's going. The intensity of sound waves or their amplitude can also tell us a lot about the object emitting them. For example, a brighter star will emit more intense sound waves than a dimmer star. Similarly, a more massive black hole will produce more powerful sound waves than a smaller one. And then there's the duration of the sound waves. Some cosmic events, like solar flares, are relatively short-lived, lasting only a few minutes or hours. Others, like the hum of a black hole, can persist for millions or even billions of years. Well, there you have it, space explorers. The universe is far from silent. It's a symphony of sound, a cosmic orchestra playing out across billions of light years. And the more we listen, the more we realize just how much more there is to discover. So the next time someone tells you space is silent, you can tell them that's just plain wrong. The universe is literally singing to us, and it's up to us to tune in and listen. Who knows what other secrets we might uncover if we just open our ears to the cosmic symphony all around us. If you enjoyed this journey into the sounds of space, give the video a thumbs up and subscribe to the channel for more mind-blowing explorations of the cosmos. And don't forget to hit that notification bell so you never miss an episode. Until next time, keep looking up, keep listening, and never stop exploring the universe and all its wonders.